Hello and welcome to Logic Apps Talk. I'm Derek Lee. In this show, I take you behind the scene to talk to engineers, program managers, designers, and researchers who made Logic Apps possible. In today's show, we'll be talking about DevOps and CI/CD, and joining me, I have Beck, our newest addition to the Logic Apps PM team. Welcome to the show.
Thanks for having me. Super excited to be here.
So CI/CD and DevOps has always been a challenging topic for Logic Apps. We have customers who are able to build their workflow quickly and easily using the workflow designer, but often ended up spending more time turning it into a CI/CD process than the initial authoring of such workflow. With the introduction of the new Logic App runtime, how has that changed?
Yeah, the Logic Apps team is committed to make DevOps for workflows easier than it's ever been before. From the setup of the developer environment to test, build, and release, we're focused on providing a seamless end-to-end experience to enable developers to go from designer to production faster than ever before. It's our absolute pleasure to present an overview of the current CI/CD experience for Logic Apps Preview. We're excited to share with you the many improvements to the process and are eager to hear your feedback on what you'd like to see next.
So Beck, what are some of the high-level differences between the multi-tenant consumption Logic App and the new single-tenant Logic App runtime when it comes to DevOps?
That's a great question because they're quite different. In multi-tenant Logic App deployments, we're completely ARM template based. In single tenant, we're enabling a more separations of concerns approach whereby Logic Apps and their workflows are deployed with a combination of ARM for infrastructure as code and normal build deploy mechanisms to push your workflows on top of that infrastructure. This means developers and integration specialists can focus solely on their workflows, and any infrastructure related setup, such as VNet integration, as an example, can be handled via separate processes and pipelines. On top of that, Logic App's single tenancy introduces a new resourcing structure whereby rather than having a one-to-one mapping of workflow to Logic App resource, you can now have many workflows hosted on top of the one Logic App's resource, reusing resources between workflows and improving performance due to proximity. This works similarly to Azure Functions if you've ever used them, whereby you have many functions with one overarching function app. And the structure when deploying locally will look something like this. This provides users a much more generic project model whereby you can apply much the same mechanisms for your DevOps pipelines as you would any generic app, reusing build steps we've been using forever, such as MS Build or .NET Build. But if you're not a .NET shop, never worry, you can containerize your Logic Apps and fit them into your pre-existing pipelines with tools and build processes as you would do normally with containers.
That makes sense. So how does the new Logic App runtime changes that? And why should I care?
That's a great question. So to start with, to enable single tenancy, we replatformed the Logic Apps engine onto the Azure Functions runtime. So above and beyond inheriting a more generic app model, as I've just mentioned. So the first and the most exciting of those being local development and test. One of the biggest and most exciting capabilities we inherit from Azure Functions is the ability to run your Logic App locally in your development environment. Previously, all development had to be against a live Logic App on Azure via the Visual Studio extension or in the portal itself. With the new VS Code extension, plus in combination with Azure Functions, Runtime, and CLI tools, we can run Logic Apps in your local development environment without needing a live resource already pre-deployed. Now, the second feature that we are introducing into Logic Apps is deployment slots. Deployment slots, if you haven't used them already, are awesome for things like blue-green deployment patterns. Essentially, a slot is a replica or a copy of your production slot running in the same hosting environment. Sharing the same environment means you can test your staging app before making the swap into production. And instead of copying the files over, it's simply just a DNS swap, making it super quick. Plus, your old code then becomes your staging code. So if you need to roll back for any reason, you've got the ability to do that really quickly and really effectively. Another big thing that we are introducing as part of the Logic Apps preview is environment variables via app settings. Now, one of the biggest challenges of multi-tenant Logic Apps is how to maintain my environment variables for your Logic Apps across various dev, test, and production environments. With everything previously in ARM, these were all deployed and defined at deployment time, which means you'd have to redeploy every time you needed to change even just one variable. With single tenant logic apps, you can now call out to your environment variables at runtime with app settings, meaning you don't have to redeploy as often, which will make DevOps pipelines and configuring those environments a lot more smoother and effective. As previously mentioned before, separations of concerns is a new type of pattern that we can inherit with the new Logic Apps single tenant. Previously, when everything was tied to the ARM template, the developer and the integration designer was to a certain extent always infrastructure aware. With the Logic App being able to be deployed as a separate build package, the developer and integration designer can now singularly focus on creating workflows, and other concerns such as the infrastructure as code side can be handled by the operational specialists. Our goal is to simplify the deployment process for everyone, to help people focus on what they need to do to build awesome workflows and faster. And last but certainly not least, as I also mentioned before, Azure Functions is a containerizable runtime, which means by extension, you can now containerize your Logic Apps too. What you do with your container after you Dockerize it is completely up to you and will fit into your already pre-existing processes for packaging, monitoring, and deployment, giving you the power of Logic Apps anywhere from any pipeline you choose. Now, these are just some of the improvements we're making, with many more yet to come, and we're really keen to hear your feedback to see what you'd like to see come next.
Cool. So how about connections? That has been one of the biggest challenge when it comes to DevOps for Logic Apps.
Yeah, great question, Derek. When it comes to connections, it's a little bit of a same but different story, with the team working on improvements in this space with changes yet to come. Now, today we have a rich ecosystem of almost 400 connectors, which you can still use in single tenant Logic Apps. The way these connections are managed and maintained is much the same in the Logic Apps preview. However, the biggest improvement comes in with built-in connections. In a nutshell, we're working to transform some of our most commonly used connectors, such as HTTP, SQL, Service Bus, etc., into built-in connections. This means that these connections run locally in the same process that runs your Logic Apps. This means that it not only improves performance due to proximity, they're actually running in the same process as your Logic App, but it also works great in DevOps pipeline, as your connectors are now packaged up into the same builder artifact, rather than having to manage them as separate Azure resources deployed via ARM.
That makes sense. So is that all the improvement the team is making for DevOps? Or are there more features to come to make that experience even better? And I think more importantly, how does a best practice look like when it comes to DevOps for Logic App today?
Absolutely. As mentioned, we are on a journey to improve the end-to-end experience for DevOps in your Logic Apps. And while there still might be some gaps today, we'd love to hear your thoughts on what you'd like to see coming next. As for what it looks like today, I think it's better to show rather than tell. So I'm going to go flick over to a demo. So before I go and flick over to that, here are just two links to some samples. One is a sample for an end-to-end pipeline on Azure DevOps, and one is an end-to-end pipeline on GitHub. Now, as I mentioned, the deployment mechanisms and model for Logic Apps is pretty generic. So you're not locked into using Azure DevOps or GitHub for these deployment pipelines. These are just quick starts to help you get going. So this is what we're going to be building out today. It's an end-to-end DevOps pipeline, taking you from local dev and test to a mock UAT/production environment. Of course, you might have a lot more environments to deploy to. This is just a basic baseline implementation. It's designed to be taken apart, designed for modularity, and designed to be extended to fit your use cases and scenarios. Now, the first thing I'm going to do is I'm going to go into my Visual Studio Code environment where I've already got the sample code cloned there. VS Code is where I'm going to do all my designer work with Logic Apps. Behind the scenes, when I'm in my designer, the designer is doing all the heavy lifting to generate my workflow.json file, my connections.json, and any environment variable that I need to pull out per environment gets put into local.settings.json. These are later overwritten by environment variables in your app settings. Now, as you can see, I've got a resource group tied to that environment with some connectors in it. Now, while you can completely develop your logic apps out of Azure, if you need any of those 400 Azure-based connectors, this is not including the built-in connectors which run locally, you will need to create and host them in Azure. I'd recommend having a shared dev resource group with all your connectors that can be reused across your dev work, and then have separate connections for your production, UAT, and other environments. Now, once I will build my workflow and I'm happy with it, I'm going to then check it into my source code repository. In this case, I'm going to be going through with GitHub, which will then trigger my GitHub actions to do my deployments. Now, to demonstrate the separations of concern that I mentioned before, I've got examples of pipelines that do just the application deployment and some that do just the infrastructure plus the application deployment as well. Now, I've opted to host my logic app resources and connections in 2 separate resource groups. This is a design pattern that allows for modularity with your deployment pipelines. Typically, your connections don't change as much as your workflows do. So having them in a separate resource group means that you can deploy them separately at slow cadences. This is a particularly useful pattern if you use a lot of actions which require manual sign-on, such as Office 365, Salesforce, and more. Less deployment for those means less manual steps. So it just simplifies the whole process. All right, so here I am in the Logic Apps GitHub repository. This is where we're going to be hosting all of those samples and templates that I mentioned earlier. This is an example of a Azure DevOps pipeline, which will actually do things like containerize your Logic app and deploy it as an app, deploy the infrastructure as code. All the ARM templates and the different scripts are in there to get that baseline deployment going. Today, I have an example which uses GitHub Actions to do that deployment. But as I mentioned before, most of these DevOps processes are pretty generic, so you can apply these to whatever DevOps tool that you have. So I'm going to flick over to my Visual Studio Code environment where I've already cloned the sample code here. As you can see, I have my ARM templates ready to go. As mentioned before, I have 2 separate resource groups, one for my connections and one for my logic apps. So I've just got 2 separate ARM templates that define the resources for those different environments, as well as the parameter files for each. I've then got a sample workflow that I'm going to work through, and I'm just going to go ahead and open that in Designer. Okay, so now that my Designer is open, you can see my sample workflow here. Now, the beauty of built-in actions is I can just simply build this project as is and deploy it to my Logic Apps environment. Everything to do with the connections, in this case it's a HTTP connection, is all built in to the Logic App process itself, and that was all you have to do. For now, I'm going to use an example of using one of our Azure connectors to show you how you would DevOps your connections along with your Logic Apps workflows as well. So for today, I'm going to use a blob connection. So I'm going to type in blob, and I'm just going to simply list out the blobs in my root folder. Nothing fancy. Now, I've already set up my environment to know that it's pointing to my developer resource group with all my pre-existing connections, which is why that's connected straight away. Because this is my first time in running this in my local environment, when I save that, you're going to see a connections.json file pop up. So as you can see, that local connections.json file was created on my behalf by the designer. This is really there for your local keys to help your Visual Studio Code environment authenticate against those Azure connectors. These will change a little bit through our deployment pipeline, and I've got scripts that I can showcase to show you how you would change this file as it goes through the build process. Okay, so I'm pretty happy with that. I'm going to go ahead and save that. So I've F5'd that, and now I'm going to flick over to Postman to go test out that local endpoint to see how that Logic App is going to work. Okay, so now that Logic App is running locally, to get the endpoint, all I need to do is right-click on my workflow, click the overview pane, and we can copy this callback URL right here. Now I'm going to go ahead and paste this into Postman. Here we go. I'm going to go send a request. And this, I actually haven't specified anything to return, so it's just going to give me a 200 says okay. And so I know that that's working. If I want to go and see the history of that and see how that ran, as you can see, it took a couple more seconds than usual. I might want to go dive into this and see what's happening in here. And of course, we have local breakpoint debugging, as you might be aware. So if we want to go and get a more granular view of what's happening here, we can go ahead and breakpoint at certain points to see what the inputs and outputs are. Cool. So now let's say we've developed our logic app, we've tested it, it's all working well. Now the next thing we need to do is check that into our source code repository so our DevOps pipeline can pick that up and deploy that out into our production environments. All right, so as you can see, I've made some changes to my workflow.json file. I've added in my new blob action, which will just find me all of the list of blobs in my root folder, and then in a perfect world, return that in the response. Great, so I'm going to say add new blob action. Now this is already configured up to my repo, which has all these different files that I've got. So this change will trigger off a GitHub action. And there we go. I'm going to sync that up and I'm going to flick over to GitHub Actions to show that working. Okay, so we're now in my GitHub repository and you can see that my GitHub action has kicked off. As I mentioned before, I have two GitHub actions, one that does just the build and zip, which will actually build that the workflow project into a build artifact, which will then get deployed onto my logic app resource if it's already created. Or if you want to do all the infrastructure as code, creating the logic app, creating the connections, and pushing the workflows to that environment, you can have a look at the second pipeline as well. Now, just to showcase what we're actually building when we run our infrastructure as code pipelines. So this is what we've created so far. We have a local logic apps project, which we can have multiple different workflows within that. And we've also got our connections.json file, which has been generated for us by the designer as we've been building out those different workflows using different Azure connections with the combination of built-in connections. Now we want to go and build out our logic apps environment on Azure. And we want to do this programmatically via an infrastructure as code pipeline. So what do we need in those ARM templates and what are the dependencies between each of those different resources? Okay, so once we've built and packaged up our logic apps application, we need to run this on something. So that package will run on a logic app resource on Azure. This logic app resource is hosted on a hosting plan, and it uses a storage account for things like state management and storing larger requests and for other metadata type purposes. For any Azure connection that you're using, not the built-in connections, but the normal Azure connections that we have in our marketplace today, these will be hosted as a separate API resource, and these will point to their backend service, whatever that connection is connecting to. Now, one of the biggest shifts from multi-tenant logic apps to single tenant is the way that your logic app resource will interact with those API connections. In the multi-tenant world, our multi-tenant Azure hosted infrastructure just implicitly trusted the API connection infrastructure that we host on your behalf. With a more single tenant approach, we need another mechanism to trust that particular calling application, so to speak. So the logic app in question now has a managed service identity, and the API connections have access policies to say, yes, I trust logic app A to do X with my backend service. So this means in your ARM templates, you'll just need one extra step, which is to add an access policy when you are creating those API connections. This means that you'll most likely need to have the logic app or pre-deployed before you run those connections. Now, the last thing to mention, we saw the connections.json file get generated for us in our local environment. Now, that's really designed for local development. So what we need to do as a prerequisite before we build and package our logic app application is we need to run a certain script to just simply repoint our connections to our production API connections that we want to use. Now, we've already built that script out for you, and it's in the baseline template. And note that we will be building in this functionality to the logic apps experience, so we won't have to call out the script further in the future. This is what the experience will look like today if you need to DevOps your logic apps. Okay, so I'm back in Visual Studio Code just to show you what those ARM templates look like. So as I mentioned, I have two ARM templates, one for my connections and one for my logic apps. And as part of my logic apps, I'm creating that logic app resource, which it will run your build application. I'm running the hosting plan, which the logic app will run on, and I have a storage account, which that will use for the metadata purposes, as you can see just from these parameters. I'm doing some variable stuff to just create a generic name so that we can spin this up from scratch every time we run it. In the connections file, I just have my blob connection already ready to go. And as part of that, I have a storage account that I'm going to spin up that it can point to. As mentioned, the identity is something that the connections need to be able to configure that access policy. So I'm actually going to pass in my logic app system identity, the tenant ID and the object ID, which in this case I'm getting as the output from the previous template deployment. But there's a whole bunch of other ways that you can get these the MSI from the logic app itself. The access policy will look a little bit like this. You simply just point it at the tenant ID and the object ID and the actual connection that you're applying this access policy to. Once you've added all this, you're good to go, and your environment's going to be set up ready to host the workflow that you've just created. So let's have a look at those different pipelines while our deployment runs. So as I mentioned, I've got two separate pipelines. I'll go through just the application build and deploy to see how that would look like. So the first thing I'm going to do is just define a couple of different environment variables. This is just pointing at the resource group where my logic app and connections are. This is just deploying to one environment, but of course you can have multiple environments that you're deploying to for things like dev, test, UAT, and prod. Some of the jobs that I have running, once this particular pipeline gets triggered off, I'm just going to check out the code. I'm going to log into Azure with my Azure credentials, just giving GitHub the ability to actually do things in my Azure environment. So the next thing I'm going to do is to call out to a script. Now, this script is something that we built on your behalf to actually generate a new connections.json file pointing at your production connections resource group. Now, the reason this is there is that, as I mentioned before, connections.json is there for mainly local development, and it's pointing at your development resource group where your connections are. If your development resource group is the same as your production resource group for your connections, then you won't need this. This is just relevant if you want to have your logic app deployed to different resource groups and different environments. So all you need to do to kick that off is just to point it at your resource group where your connections are, and it will do all the heavy lifting for you. Once you've done that, you need to get the publisher profile of your logic app that you want to deploy your package onto. I'm just running some inline scripts to do there, but there's a whole plethora of ways you can do this. Once I have that connection profile, then I'm just going to set up my .NET environment on that particular build process under the hood. I'm then just going to run a .NET build, which will then package up all these different files into an output folder. And then I'm going to reuse the Azure function at GitHub action to deploy that zip file to the right environment using the publisher profile and the name of the logic app that I want to deploy it to. Now, note that under the hood, this is just a zip deploy. So you don't need to use the Azure functions GitHub action. You can use any form of zip deploy mechanism in your existing DevOps tools. We will have a logic apps GitHub action. That is a roadmap feature. I'm very excited for that. So if you've got any feedback of what you'd like to see in that, we'd love to hear it. So that's our application build pipeline. Now, what does the infrastructure as code pipeline look like? Well, it looks very similar. In this particular pipeline, I have both infrastructure and application deployment in the same. As I mentioned before, this is a simple baseline deployment pointing to one environment. You can absolutely rip and modularize this however you'd like, having separate pipelines for each component to multiple different environments if you need. So a similar thing here, we're just pointing it at our resource group that we want to deploy to. We're doing an Azure login so that we have the ability to create resources on our behalf. We're going to check out the code, and then we're going to do an ARM deployment. Now, I'm first going to deploy my logic app and the hosting plan and the storage account. That will give that logic app a managed identity, which I'm then going to pass through as inputs to my second ARM deployment, which is for my connections. Now, once that's all done, Then I'm going to do the build and the application work that I just showcased earlier. So there you go. That's a very simple but end-to-end pipeline, creating my infrastructure for me on the fly, doing all of the access policies and plumbing together of everything those different resources need to host my application, which in this case is a Logic App workflow. So if I come here, this is the one I just ran. It ran about 14 minutes ago. So here we go. Let's go and have a look at what this looked like. So this is the infrastructure as code pipeline. So these steps again, sets up job, log in, deploy my Logic App to my Logic App resource group, deploy my connections to my connections resource group, reconfigure that connections.json file to point to my new connections group, get the publishing profile, do the build for my application, publish that zip file to the Logic App, and then run any tests that I might need in between. So this is what that's going to look like in Azure. So if I go to my GitHub app resource group, which is where I hosted my app resources, you can see based on the crazy wacky names, I did generate the names to be unique every time. I've got my hosting plan, which my Logic App will run on. I've got my Logic App itself, and I have my storage account for all the state and the metadata to do with that particular Logic App. Now, if I go drill into this, I should see my new workflow. It should have my blob action already there, and that blob action should be ready to go, access policies configured, so I can just run this, test this, get the endpoint, and go from there. So to validate this, we should see our workflow. As you can see, our storage request workflow that we were working on before, and we should see our new action, which has been pushed up to this environment. There you go. That is using the new connection that I deployed via that pipeline, which is actually in my GitHub connections resource group, a separate one. So here we go. Here we have the Azure Blob connection that I created via that second arm template, as well as the storage account that is connecting to list out the blobs. If we go drill into this, we've got no problems. It's connected. All the access policies are configured, and we're ready to go. And that's it. So the steps again are build your workflow, make sure that your ARM templates reflect the connections that you have in your workflows, deploy them either as just the application on top of the environment itself, or in a combination of infrastructure and app, depending on what you're already doing today in your DevOps environments, and then go from there and deploy it to as many environments as you want. All of this was completely automated under the hood. The pattern that I've showcased here is a pattern to help reduce the amount of manual logon steps if you are using connections such as Office 365, Teams, or Salesforce or other. Okay, so to recap what we just went through, we started from a template, which in this case was going through an end-to-end process to deploy your Logic App using GitHub. We also have a sample for Azure DevOps. But if there's any other samples you'd like to see, we'd love to hear your thoughts and feedback in the link below. In terms of features, this is a work in progress. Today, I showcase what you can do with Logic Apps and DevOps today. We hope that the improvements will improve your lives as well, but we know that we've got a couple more features in the pipeline that we know you'd love to see. So in terms of what's coming up, we will have Deployment Center unlocked soon. We'll have our own GitHub action, as I mentioned. More docs and guidance will be coming as we go closer towards general availability. And any other feature that you'd love to see, please let us know. We are welcoming feedback. And yeah, feel free to use those resources and let us know how you go.
Now, that's some great information you have shared. If people want to learn more or take a look at the script that you shared, where should they go?
So the demo projects and all the scripts are uploaded to Logic App's GitHub repo. We'll put a link in the description below so you can give it a try.
Awesome. So this is the new DevOps experience for the new Logic App runtime. If you haven't given it a try, please do. It is in public preview, and we would love to hear your feedback. Thanks for watching, and see you next time.